Hey everybody, this is Mr. Morris talking a little bit about single replacement reactions, both identifying and then predicting the products of a single replacement reaction. So if you think back to the notes we've taken in class or to one of the previous videos, we can identify a single replacement reaction because it involves a single element, which is usually a metal, trying to react with an ionic compound that contains a metal and a nonmetal, or in more general terms, a cation and an anion. And we want to see if the metal that's by itself is more reactive than the metal in the compound. We know this reaction is going to happen. So I look at the example we have on the page, and sure enough I have a single element, which is potassium, which is a metal, trying to react with an ionic compound of copper fluoride. And so now what I need to find out is, I know this is a single replacement reaction. I need to find out, does this reaction actually happen? So what we think might happen, if everything works out okay, is that the potassium right here will come over here and try to kick the copper out of this compound, send the copper off by itself, and take its place. The only way that'll happen, though, is if the potassium is more reactive than the copper, which is the metal in our compound. So I go to my periodic table, I come down here to the bottom to the activity series for metals, which is a chart of reactivity, and I simply look. So I try to find the two things we're talking about. So here's potassium, and way over here is copper. So that means that because the potassium is farther to the left than the copper, it's more reactive. So that means because potassium is by itself and it's more reactive, the reaction will happen because the potassium has enough strength to kick the copper out of the compound and take its place. So sure enough, we're going to have the potassium come over here and kick good old copper out. Works better if we use a pen as opposed to a highlighter. Let's try again. Potassium comes over here and kicks copper out. So I know this reaction will happen. So now I need to predict the products. So what I'm going to get is potassium becoming part of the compound, hooking itself to fluorine, and copper going off and being an element by itself. The last thing I need to do is, because we created a compound, which is this guy right here, the KF, I need to figure out the charges on each ion. Get my pen to work here. So potassium's 1 plus, fluorine's 1 minus, which means that those cancel. I don't need any subscripts in that compound. The formula is written correctly. So the last thing I would have to do is go back and add coefficients to balance this equation, which, if we're going to do that here real quick, let's see, we would need a 2 right here and a 2 right there. And we should have 2 potassiums, 1 copper, 2 fluorines, and we're balanced and good to go. Let's try another one. This time, actually we can just type it out here. So let's say we have some silver metal that's trying to react with some lithium, let's go here, chloride. And so I look and say, okay, we have a single element, which is a metal, trying to react with an ionic compound. So this is a single replacement reaction. But does this reaction actually take place? Is the silver more reactive than lithium? Which means, is the silver strong enough to come over here and kick lithium out and take its place? So that's what we got to figure out. So again, we go back to our periodic table. I go to my activity series for metals. I find silver, which is way over here. I find lithium, which is the very beginning of the list. And this time, because silver, the single metal, is farther right than the lithium, it's less reactive. So that tells me that because silver is less reactive, it doesn't have enough strength to kick the lithium out of the compound. And if you can't kick him out, the reaction can't happen. So silver tries to kick lithium out. He comes over here, it doesn't work. And so nothing's going to go on. So instead of getting any products, even though this is a single replacement reaction to begin with, because silver is less reactive than lithium, I simply write no reaction, and I'm good to go.